presentation of this, which you have for 10 marks. And the guest talk which was scheduled today, the person from industry has got a release today. So he said that he'll be taking on Monday. So let's see how it works. Okay, now without wasting much time, we'll proceed. Okay. Yeah. We started with daemon process. As I said, daemons are the process which runs in the background, and daemons have super user privileges. That means a process which can't be stopped by the user, or the process which is not under the control of users, are called as daemon process. And there are no shortcuts, no buttons, anything to stop those processes. Okay. So the process which can't be stopped by the users are called as daemon processes. They don't have a controlling terminal. That is what is said in the previous class. Just like the taskbar.exe, which is a process runs in your Windows, it's a daemon process, right? So again, we said about daemons are nothing but sessions and group leaders, because they are created by the user in super user mode. So once they're created, they become their own leader. That means no other process can stop them or terminate them. This is only possible when a process becomes a session and group leader. This is SID and GID, we call it as. So the process whose ID matches GID is nothing but a group leader. The process whose PID matches the session SID is nothing but a session leader. Okay, this is what we studied in the previous class, and we discussed about how a daemon process looks like. Right, all the daemon process by default usually ends with an alphabet D in it. So the process which ends with D, and see, for them TTY, when you say PS minus AJX, A is nothing but for all others, X are nothing but daemon process, or the process which don't have a controlling terminal. So how can I rectify this? This can be rectified only with the TTY terminal. The terminal, wherever it is question mark, indicates that these are the processes which don't have a controlling terminal, and they keep on running when the process starts, and they stops when you shut down your system. Okay, that is also. And a process ID whose ID is equal to the session ID becomes the session leader. Okay, it becomes a session leader. Please remember this. Now look at this process, PID 1009. Now this is a daemon process whose ID is equal to the group ID, whose ID is also equal to the session ID. That means this is a daemon process which has no controlling terminal, whose ID is equal to the process group ID as well as the session ID. Okay, and we discussed in the previous classes about this characteristics of daemons. Now the next question comes is, which we studied about, which all different daemons are here. So if you see the network terminology now take an example of your mobile phones only. The minute you use your smartphone, right? At the end of the day, you just go to systems and you just check, right? Data usage, battery usage. What will happen there? It will show you the complete flow, like how much battery was used for which app, how much battery was used by this app, how much data was used by this. All this details you'll get it. So how you are getting this? Because there is a process which is running at the backend for you. Whenever you start your mobile, there is a process running at the backend, and you can't stop that process. So that is a process. Such processes are called as daemon processes. I gave you the example of Windows also. See, so if you go in Windows here, I'll just see this. Alt Control Delete. Alt Control Delete will take you to the taskbar. So in taskbar, here the process which are running here, which you can read it, are called as user processes. The naming conventions which you can't read it, you can't pronounce it, are the daemon. These are nothing but the system processes which are started when the system starts, which stops when the shut down the system. And by default, if you try to force this process to close it, Windows log. So if you close it, your system only crashes over there. So these are the processes, daemon processes in Windows. On similar lines, we have daemon process in Unix also. Okay, so this is what we started about the daemon processes. Okay, next are the coding rules. Very important here. In the exams, they can ask you. The different types of questions can be asked. What are daemon processes? Explain the characteristics of daemon, which we said in the previous class. We can explain that. Or they can ask you what are daemon processes and explain the coding rules. That means how you can write a user daemon. Now, sir, you explained about daemon processes, but you did not tell us how to create a code for daemon. Okay, so coding rules will tell you the ways in which you can write the code for a daemon process. Okay, the coding rules are there are rules, and I'll tell you this code also side by side. The first rule says that call fork and have the parent exit. Call fork and have the parent exit. What it means now? Because as I said, whenever a process is running, daemon process, it is not under the control of anybody. No other process can control it. So how can you make a daemon process at the initial level? First and the foremost thing is you create a process, child process, and make the parent to exit. Because if parent is also executing, what happens there is parent will still have a control to stop the child process with some of the signals we studied, right? Parent can ignore the child, it can take the default action, or it can call the user defined function. So if at all you want to create a daemon process, first rule says that call the fork and have the parent exit. Now look at this piece of code. Okay, we'll go side by side. I'll just go make use of alt tab. Conventions will take it later on. Okay, now assume that in the main code, first and the foremost thing is PID underscore process ID I have defined, because process IDs are defined by the data type PID underscore. I hope this is visible, or else I'll just increase the font size. Yeah, this is fine, I guess. Okay, see, PID underscore process ID is 0. So what I'll do is I'll create a child process. Now please look at this. What they say, call fork and have the parent exit. That means you create a child process. So fork will create a child process. I know this. So whenever a child process is created, its status is written in process ID. So if process ID is less than 0, obviously the fork has failed. That means the child process is not created, and you stop the process. If not, if the process ID is greater than 0, if the process ID is greater than 0, then you will write its child ID and you will make the parent exit. See, what I mean by exit here now, that means you are making parent process to stop, because what the rule says, first rule says is call fork and have the parent exit. That means how can I exit the parent? In the fork, sorry, in the fork. So I call the fork. If less than 0, can't be created, but if it is greater than 0, that means you are in the parent process. If it is equal to 0, you are in the child process, but if it is greater than 0, the control is in the parent process. So what it does is it writes the process ID of the child just to display it, and then you have called the exit function. Now what does the exit do? Exit will stop the process. What has happened here? Child is created. Now you are in the parent process, right? See here. Fork. Child is created. Once child is created, now you are into the parent process. Once you are in parent process, what did you do? You have exited the parent. Exit system call is used to stop the process. Now which process is being stopped? This parent process is stopped. The child is still running. So the first rule says that call fork and have the parent exit. What happens first? If the daemon was started as a simple shell command, then the parent terminates, makes the shell, that command is done. Second, the child inherits the process group ID of the parent, but gets the new process ID. So we are guaranteeing that child is not a process group leader, right? This is what is happening here now. Because once you terminate a parent, now the child is not under the control of parent and it is running independently. Because daemon says no process should control the daemon process. Second thing, call umask function to set the file mode creation mask to 0. Now what is umask function here? Now see, what did I did next now? Once the parent is terminated, I have called umask 0. Now what is umask? Umask is nothing but the file permissions, the permissions for a file. Now what are file permissions? I have told in the octals initially. 777 means read, write and execute for owner, read, write and execute for group, read, write and execute for others, right? So whenever any files are created, by default they get some file permissions like read, write, execute, whatever these are. Just like here, if I show here till it starts, So what happens there is, whenever a file is created, there are some default permissions given to file by default. You can change them later on, up to your convenience. But whenever a file is created, the file has default permissions whenever it is created. That means once a daemon is running, neither you can write into the daemon, neither you can read the daemon, nor you can execute the daemon, because it is not in the user control, right? So for that, what you should do is, whenever a process is created, you remove all its permissions. So umask is used to remove the default permissions of a process. Umask is used to remove the default permissions of a process. So whichever the processes are running, all those default permissions are removed by the system called umask. Okay. So see, I'll show you here how exactly it works. Okay. Now here in the terminal, if I type ls minus l, it will show me long listing of files. Now look at this permissions. Now look at this file. Okay, leave our directory files. Now see, these are the default permissions: read, write, execute for user, read and execute for group, read and execute for others. Maybe these are the default permissions whenever a directory is created. See, you can see this. For directory, maximum permissions are same only: read, write and execute for group owner, read and execute for others, read and execute for group, read and execute for others. So what happens whenever you create a directory? By default, it gets this permissions. Similarly, for files, whenever you create some files, by default, files may get some this permission. Now look at this. These are the files. If I say ls minus l, it will show me long listing of files. And if d is prefixed, it means that it's a directory. If dash is there, it means it's a file. Now look at this. Install.log and install.log.syslog are the files. So what is happening? By default, whenever a file is created, these are the permissions for a file. So what is my task when I'm creating a daemon? The task says me that whenever you're creating a daemon, call umask function to set the file mode creation mask to 0. So umask is a system call in Unix. It sets the file mode creation mask to 0. Whatever are the default permission are removed and it sets to 0. That means no read permission, no write permission, nor execute permission. Whenever I call this system call, that is what the file mode creation mask that inherited could be set to deny certain permissions. If the daemon process is going to create files, it may want to set specific permissions. So what did I do now? I have terminated the parent, then I have called the umask. Now umask will remove the file default permissions. Okay. Now once this is done, the third rule says is call the set SID to create a new session. Now set SID is a system call which creates a new session. Please remember, now session is what? See, the class what is going on? It's 1 hour session. Who has created it now? I have created the session. So if at all you are logging it with some other ID, it will ask me the permissions. If you ask with logging with your Gmail ID, it will ask me permission, admit or not. But if you log in with GHO or DDO, automatically you are admitted in this session. So similar lines, first rule says that let parent create a child process and parent terminate. That means now the child process which is running will not have any other process which will control that child process. Second thing says that call the umask function to remove the default permissions of a process or file. So umask will remove the default permission. Read, write, execute, read, execute was there. So those are removed and all are made at 0. That means there is a file or a process which can't be read, which can't be written, neither can be executed by user, by group, or by others. And the third rule or the third step says that call set SID to create a new session. So what happens? Now child is only running, and if child calls a SID, now it becomes a session leader. Same thing what is happening for our Google Meet now. Since this Google ID is generated by me, now I am the author of this or I am the owner of this ID. So if at all you are admitting, it will ask, I should give the permission. I can still have the permission to mute you, unmute you, and do all this from my end, because now I am the leader for this group. Same thing happens with the WhatsApp group also. You have admin, group admin, right? Almost in our group, everybody is admin there. So what happens there? If you are a group admin, you can have the control over the group. Same thing, whenever daemon is running, it should be a session and group reader, which was told in the characteristics. So how can I do that? That can be done by calling the system called set SID. Set SID will create a new session. So whichever process called set SID, that becomes a session leader, because it becomes a session leader of a new session, becomes a process group leader of a new process group, and has no controlling terminal. See, whenever I call SID, these things happen. The process which is calling becomes a session leader, the process which is calling becomes the group leader, and it also has no controlling terminal. So what did I do now? I've called umask, then I've called set SID, and I've assigned it to the file descriptor SID, because I've declared a process ID here again as stated. Now what is this SID? It is equal to this process ID only, because you are in the child process. Okay. Now that becomes your session ID. Now again, just check, if SID is less than 0, it's failure. Okay. If not, you have created a session. So third rule is very clear. First thing is create a child process and terminate the parent. Second rule says that remove all the default permissions of the file or process by using calling the system called umask. Third rule says that the child process which is created, you make that as a session leader as well as a group leader, because in characteristic it is told. See, again go back to this. Here it was told daemons are session and group leader. Now how can I make them a session or group leader? By calling the set SID system. Okay, done with this. Next thing what we should do, as I said, daemons should have super user privileges. That means they should be working in the root directory only. So once a process becomes a session group leader, change the current working directory to the root directory. So probably from wherever you have created this. So here, present working directory. Here, PWD. Now this is my present working directory, which is I'm already in the root, but maybe you have worked in some other directory and all. What you should do is, what the rule says is, change the current working directory to the root directory. That is, the current working directory inherited from the parent would be on a mounted file system. Since daemons normally exist until the system is rebooted, the daemon stays on a mounted file disk. The file system cannot be unmounted. So for that, you should keep or run the daemons in the root directory. Now how can I change to root directory? By calling the system called chdir. Chdir is a function which changes the current working directory to the whichever directory I want. Now right now I want in root. We all know root starts with a forward slash. So this. So this is clear. I made them a session leader. I changed them the current working directory. Next, very important. Unneeded file descriptor should be closed. Now, what is the unneeded file descriptor? That is, whenever you should not have standard input, standard output, and standard errors, which are running in your process. You have standard input, you have standard descriptor 0, 1, and 2 for error. All those should be closed, because no file descriptor should control your daemon process. That is the rule says. So what does the next fifth rule say? That unneeded file descriptor should be closed. That is, this prevents the daemon from holding open any descriptor that it may have inherited from its parent. So this can be done only when you unmount it. That means you close those file descriptors. And how can I close this? I have a system called close, which will close that. So close unwanted file descriptors. So close std in underscore file no, that is standard input. I'm closing it. Std out underscore file no, I'm closing for that file standard output, because it is running in the backend. Should not run on my output file, and no error should stop it. So std err underscore file no. So I'm closing this standard input, standard output, and standard error. So all these are closed for me. So this is the fifth rule. Sixth rules. Some daemon may open the file descriptor 0, 1, and 2. That is init process 1 and 2 to dev/null. So that library to try to read from standard input or write to standard output or standard errors will have no effect, because the daemons, since the daemons don't have any controlling terminal, there should not be any output to be displayed, nor anywhere from the input to be interacted with the user. This is what a daemon process says. So daemon started to interact, and daemon, how it will become a daemon? Because since daemons are running in background, the login session can terminate without affecting the daemon. So for that sake, what you should do here is, once you do that, now the file which I'm creating, log.tsc in write mode, what I'm doing here is make the process sleep and stop all the processes. So there are various ways of writing a daemon. Okay. So what I'm doing is, for that process, since it is true, it goes in infinite loop plus fp. That means stop all the file descriptors which are associated with that process. Remove all that. So once you remove all that, there is nothing to be written, and for all those file descriptors, you just close all those file descriptors. So once you close all those file descriptors, now there is a process which is running, which has no user control, parent is terminated, child is executed, it becomes the process leader, it becomes the group leader. You are running that in the root mode because it has supervisor privileges. You remove the standard input, standard output, and standard error, and other file descriptors which are associated with it. You also have to close them. So all that if you do in a coding way, then this program which I've shown here becomes a daemon process. So once you run this, now since I'm in a virtual machine, I can't demonstrate it. If you have installed Fedora, run this piece of code and just check it out. Once you do that, now it will terminate, it will go. Nothing will show on the output screen. And when you run that ps-axj, whatever the name you have given, that name will be displayed on the process terminal code. And this is how you have to write the code to create a demo. Now these are the coding rules. These are the coding rules which help me to create a daemon process. Is this clear, students? The exams usually ask for 10 marks. Explain the coding rules of daemons. More than that, they may ask a program also. So this is sufficient. Each rule, there is a reference given in the program mode. So this is how you can create a daemon process. Again, as I said, I showed you this code here also. I've written this code here also. Okay, it's up to you how you do it. Okay, close the standard input, log, sleep, flush, implement and call some of the does core work for this demo. So I'm closing all that. That means there's a process which is running, which is in the root directory. There are no file permission. I'm closing the standard input, standard output, and standard error so that nothing should interrupt it. Open that file in the write mode and let it keep on working as a demo. Okay, this is how you create a demo. This is a sample code for demo. Just simple demo. If you can execute this and just check it out, nothing is done. So what I did here, I've called a for process. If not equal to 0, that means if it is in a parent process, exit the parent. Now child is continuing, call the set SID, which is nothing. This is a snippet of code. Change the directory, umask 0, return. So this is a sample code of demo also. In the exams, if they ask for 10 marks without or 5 marks, write the coding rules, and this sample piece of code is also more than sufficient for you to explain the things. Okay, so this is all about your daemon process. So in this class now we studied about what are daemon processes, what are the characteristics, and what are the coding rules. Usually they ask this only question for 10 marks. What are daemons? Explain the characteristics for 10 marks. Or what are daemons? Explain the coding rules for 10 marks. Okay. So we'll take a break of 10 minutes and we'll come back at 11. Is that okay? Understood, students? What are daemons and the coding rules? The slides and all, once I complete, I'll share the slides with you. You can run in your Fedora and just check it out, how you will work a daemon. Okay. Attendance will take in the next class only. I'll come back at 11 to 11:45. We'll continue the next session. Because as I said, daemons is very small concept to be told, and you can get good marks in this unit also. Okay. So I'll stop recording for time being. Yeah, and I'll join the class at 11 o'clock. Okay. And take a break.